Right, so as you can see on the previous example, as the numbers get bigger, the y value gets closer and closer to a certain, it doesn't keep going up forever. So we could have done minutely, we could have done secondly, which we're going to do here, hourly and minutely, and we're going to see that it's actually not going to change very much. So notice above that your account will not continue to increase even though the number of times it is compounded continues to increase. This is the limit of the function. So that's a calculus word right there. So let's see what a limit actually is. So here we're going to make everything ones so that it stays pretty much steady. And the only thing we're going to change is the number of times that it's compounded. So here, annually means we compound once a year. Semi-annually is twice a year. Quarterly would be 4 times a year. Monthly is 12. Weekly is 52. Daily would be the 365. Now for hourly, how many hours are there in a year? Well, we take the 365 and multiply it by 24, because there's 24 hours in a day. 24 times 365 is 8,760. And then to get the number of minutes in a year, you take that number and multiply it by 60. So we could do secondly as well, multiply that number by 60, but we'll see it with this one right here. So this times 60 is 525,600. Multiplying each of those in order. So now what we're going to do is we're going to take that number and plug them in for ends. So I'm just going to copy paste like I was doing earlier with this formula. So 1 times 1 plus 1 divided by, the first one is 1 to the 1 exponent. And we get 2 there. I mean, we could have figured that one out, but we'll just put it as 2. So now I'm just going to copy and paste and change the exponent and the denominator. So then the exponent becomes 2 for the next one and 2 for the denominator. Oops, 2. And here we get 2.25. And continuing, I'm not going to write them all, but I'll get them on here and you can just copy them. Changing this one to a 4 and this one to a 4. 2.44. Changing it to a 12. And this one to a 12. 2.61. I mean, more decimals, but that's enough. Now 52 for the weekly, 52. And then change the denominator to a 52. 2.693 if we go all the way to 3 decimals. And then going to the daily, 365. And then over here, 365. Oops. What did I do? Oh, I forgot the parentheses. So 2.7145. So here, keep it at 3 decimals. 2.715, you can round it to. Because now it's going to start getting very close to each other. So 8760. And then over here, 8760. Make sure I close my parentheses this time. 2.7181 is what this one is. And you should start recognizing that number. So 0, 0. And then go change this one to minutely. 5, 2, 5, 6. And we get, I didn't put my parentheses again. 2.718279, blah, 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 blah. So notice this part is the same from before. So before the error, 2.718279 2.718, 2.718. So that number we saw when we were graphing last week. And it is the number 2.71828 ... This number is called the natural base. And we write the natural base with the letter E. So E is a number, very similar to pi. So these, I know it looks like it's starting to repeat, but it's never going to be the same over and over and over again. It looks like it's 2828. But if you go further on, it doesn't continue that. So here, remember the E number, you do the second button, and then you do the divide button, and that's where you'll find the number E. So at the bottom, it says the natural base E can be treated like other bases. All the properties of exponents, transformations, and graphs act the same way. So we'll do a little bit more operations on Thursday with E. I want to do the last formula today. So let's do the E formula, which is PERT. I call it PERT on page 21. So we use PERT when it's compounded continuously. Continuously means every second of every minute of every hour of every day it's being compounded. So an infinite amount of times, but when it's infinity, it's that limit for E. So that's what the E is here. So E is the continuously part. The P is the same as it was before, your principal amount. The R is now part of the exponent. So the R here is your rate as a decimal. And the T is your time in years. All right, so example 14, you deposit $3,500 in an account that pays 4% annual interest, compounded continuously. What is the balance after 5 years? So because it says that continuously, I know I'm going to use the PERT formula instead of the compounded interest formula. So P is the 3,500. So 3,500. I know I'm going to use the E because it's continuously. And in the exponent, I multiply R and T. So R is 4%, which is 0.04. 0.04 times T. And it wants the balance after 5 years. So T is 5. So times 5. So now we can just type all that in at once. And you could do the minutely one, but why type all that in when you can just do E? So 3,500. Second divide is the E button. And then for the exponent, you put 0.04 times 5. And we get that the balance would be $4,274.91 if we were to round it to the nearest cent. All right, so the other way you can get the second divide is just the number E. If you want to automatically make it as an exponent, it's second ln automatically gives you the E with the exponent. So you can also do it that way. So I'll do it that way this next time. It's shorter. You don't have to do the caret sign, but it's the same E. All right, so for 15, so I'll do 15, and then 16 is with the graph. So it says you deposit $4,800 in an account that pays 6.5% annual interest compounded continuously. What is the balance after 3 years? So this part's still the same. The $4,800 is my principal. So $4,800. 4,800. I know to use the E because it says continuously. If it didn't have the continuously, it would say annually or daily, and that means I use the other formula, NT. All right, my rate, 0.065, because I move it back twice. Multiply by 100 is 2 decimal places, so 0.065. And I'm going to multiply that by T, which is